Hey everyone, in this episode I'm going to be taking a look at this FOKOOS FDM 3D printer. So I just took it out of the box and removed the foam. And one of the major selling points of this printer is that it can be set up in minutes. And apparently all you need to do is tip this end up and tighten some screws down, and then you're ready to print. So if you're new to 3D printing and 3D printers and you don't know how to put them together, this might provide an easier experience for you. This is the nicest free filament packaging I've seen. A lot of times they just coil it up and give it to you in a bag, and it's like, what am I supposed to do with this? Okay, and flip it around, do the same on the other side. Remove these two pieces of foam. Put this in right here. Alright, let's give it a quick look over. Looks pretty good. Okay, let's go over the features of this machine. So we've got a touch screen here on the front, so I can control all sorts of functions. Seems to be pretty fast and responsive. On the right side we have our SD card. This heated bed is pretty much what we've seen from a lot of other 3D printers. I like this extrusion with a nice flat surface. It gives it a much cleaner look. And all the electronics being contained in the space looks really good too. Looks like we got a volcano hotend with a filament runout detector, and all the cable management and wiring is done with these ribbon cables. And we've got some spares, so if these break or burn out for some reason, we can replace them. But these ribbon cables give it a nice clean look. As you can see, you don't have this mess of tangled wires hanging off like you do on a lot of other budget 3D printers. Everything I've seen on this machine so far looks pretty impressive. If we look at the Y-axis support, this is a very good design. It's got a dual rail system here. You've got a lot of distance between the two tracks that the wheels ride on, and this gives you a lot of stability. On the higher end Creality products, you'll find a setup like this, but on the Ender 3s, you'll usually have just a single bar in the middle that the wheels ride on. If you look along the back, you'll see we've got dual Z screws. You can see here, this gantry is super stable. Overall, it's looking like this is a much better deal than any of the other budget 3D printers. But we'll put it through its paces, and then we'll compare the results to some other budget 3D printers that you might be considering in this price range. Alright, so I just finished my first longer test print, and that's this White House model. It took over a day to print this base part, and it's a good break-in test that I like to do on my printers because it's a very long print and it has a lot of retractions, so it really tests the reliability of the machine. I had an issue with the filament runout sensor being triggered during printing, and twice it stopped and I needed to press a button in order to restart it. I'm going to look into disabling that filament runout detector, because I don't really need that feature, and if it's going to get in the way of me printing, I'd rather just take it off. And the other issue I have with this print is, well, watch this. It's really stuck on there. You can see it doesn't want to come off, even when I really bang on it. So I'm going to try removing this one last time. I'm going to install this PEI print bed. I'll just peel the sticker back away and plop it on here. I just finished printing the second White House model, and we'll see if this one comes off any easier. Yep, that's nice. Also, I didn't have any unnecessary stops in the print because I disabled the filament runout detection sensor. Here's the White House model of the FOKOOS Odin in its stock configuration. You can see we've got really nice layer lines, but there are some deficiencies. This pillar broke off, which is pretty common on a lot of printers. These chimney tops are supposed to be flat, but you can see here it curls up a little bit in a way it's not supposed to. The Ender 3 V2 actually does a really good job of making these chimney tops flat. So that shows that it has very little tendency of curling when you're printing overhanging features. Now let's take a look inside of this base to see what kind of electronics they've included inside. So it looks like we have a power supply. It's not a Meanwell, but it's a fanless design, so that should help the machine run a little more quietly. We've got two fans that help add circulation to the case. The screen and the motherboard are both called Maker Base. It looks like you can get replacements for these pretty cheap. Now if we take a closer look at the main board, you can see we've got our 4 stepper drivers here. You can tell there's a ton of room for upgradability. Got a bunch of spots for extra sensors, and a bunch of other ports for upgrades. If you look in here, you can see there's room to add another stepper driver. So if you wanted a dual extruder system, you could get that going. If you look down here, we have the power cables for the heated bed, the extruder, and there's extra ports if you had a second extruder that you needed to heat. So another thing is you have removable stepper drivers here, so if one of them burns out, it'll be really easy to replace it. And they've also got some really nice big heat sinks on here. So it looks like we've got the cables for the heated bed coming out down here. We've got a majority of the cables coming out over here that go to the hot end. And then we've got a couple wires coming out on this side which power that second Z-axis stepper motor. So I'm going to flip this back right side up and we'll take a look at where those cables go on the other side. So a majority of the cables that were coming out of the motherboard were coming over here, and they're entering this area under this black plastic shroud. So I'm going to take this plastic cover off and we can see what's going on under there. So I had to unplug the ribbon cable here in order to pull this out, but you can see here all of these cables are going into this PCB that converts these regular wires into a ribbon cable connector. Now what I'm interested to see is how many open channels there are on that ribbon cable. It looks like I have 5 connectors to work with if I want to do any additional modding to this machine. So this connector comes out here, makes a 90-degree turn right there, and then it goes all the way up through here up to the top, and then bends back down and plugs in right here. I've removed the protective cover on this PCB, and now you can see it takes in the ribbon cable up at the top and breaks it out into a couple wires that go to the X-axis motor and some more wires that go to the X-axis limit switch. And the other important thing that it does is it transfers all the electrical signals and power from this ribbon cable over to this ribbon cable so that it can be carried to the hot end. One funny thing about this machine is that all of the stepper motors for the X, Y, and Z axes are larger than the typical ones you find on an Ender 3. They're about 25% bigger. On the other hand, the extruder stepper motor is about 25% smaller. I want to get a better idea of how this hot end works, so I'm going to remove this heatsink. It looks like this is just driven directly by the stepper motor. So there's no gear reduction here. This is the switch that controls the filament runout detection sensor. So I got a nozzle to replace the one that comes stock on this machine. While this is heating up, I want to talk to you about the tools that I like to use to do this. So this is a Knipex wrench pliers thing. I'm not sure exactly what to call it, but it's like halfway between a crescent wrench and a pair of pliers. I like using this tool because you can see with this other nozzle, once you've unscrewed it all the way, you're actually still holding on to it. Versus the cheap wrenches that come with the machine, when you've unscrewed it all the way, you just keep unscrewing it, and eventually it comes loose and it just falls onto your print surface. Then it might like bounce off the table and melt something or burn you. So with this, you maintain positive control over that hot nozzle at all times. Alright, let's start loosening it. At 220 degrees, this thing is strangely difficult to remove. Ugh. Shouldn't be this hard. Yeah, this is weird. Alright, well I'm just going to power it out of there and we'll take a look at what's going on. Oh well, that's messed up. So now I guess I'm just going to replace the whole hot end instead of just the nozzle. So I was planning on saving this product for another video. This is the Biqu H2 extruder. It's a direct drive extruder with a built-in gearbox and a super tiny stepper motor, and they claim to have one of the lightest direct drive extruders on the market. I think I'm just going to try replacing this whole thing. This will be a good test to see how moddable this printer is. Given that it has this ribbon cable design, I think that might be a concern for some people that it'd be more difficult to mod. But hopefully I'll prove that it's just as easy to mod, if not easier, than a normal printer. So if I'm going to install this H2 extruder, I need to finish taking the stock one off. So I'll keep loosening these screws until I can remove it. I think that's all that's holding the rest of this extruder on there. Alright, now I'll remove this breakout board. This will allow me to interface my other extruder with this ribbon cable. Alright, so you can see how this breakout board works. Basically we have the ribbon cable going in on the back side, and on this side we have our 5 unused ports that we discovered on the other end of the system. We have our thermistor, our heater cartridge, our hot end fan, and our part cooling fan. And then this powers the stepper motor, and this is for the filament runout detection sensor, which I disabled previously. Alright, so somehow I've got to attach this extruder into this spot. So it's Dremel time. I'm just going to hit the spot weld right here and the spot weld down there. So I want to bolt this hot end on just like this. There's two holes in the back. So basically I just need to drill those two holes into this plate, and then I can attach this just like this. I just have to make sure that the nozzle is the lowest point and not this little thing. Alright, so I got everything wired up again. It's actually pretty easy. The only thing that was a little tricky was I needed a way to trigger this X-axis limit switch. So I bent this part of the fan protector so it gives it a little high five in order to signal that that's the X0 position. These springs were a little bit too short after I installed the new hot end, so I did have to stretch them out using 2 pairs of pliers and just pulling them, and I made them about ½ a centimeter longer. Another thing I want to address with this printer is the fans are kind of loud in the bottom. You can hear if I stop them, the machine gets a lot quieter. And what I'm going to be installing is this large Noctua fan, and I have 2 low noise adapters followed by a 3-pin to 2-pin adapter, which I had to clip a little bit to get it to fit, but I didn't have to do any soldering. This 3 to 2-pin adapter is compatible with the standard fan mounts found on most 3D printers, so I can plug this directly into the main board, and our fan is working just as it's supposed to. I just finished making the cutout for this sheet using this pair of nibblers. Alright, so now I've got my fan installed, it's all wired up, and I just gotta put this back together. Now I'll just pop my squash ball feet in here, and we're done. I found a fan mount for the BIQU H2 extruder, so I can attach this 50-15 fan to it. But before I attach this fan, I'm going to need to attach a JST connector to the end of it, so that I can plug it into that breakout board. So first you'll need to load a crimp into this crimper, and then insert the wire to the right depth, and then crimp it all the way down. And then you'll have a new termination on this wire. Once you've crimped both of the wires, you can insert them into this JST connector. So you just insert it so that the little locking tabs lock in right there. And they'll go in just like this. And then you won't be able to pull them back out. So let's take stock of all the modifications I made to this machine. The most important upgrade I did was changing the hot end to the Biqu H2 direct drive extruder. This is a really high performing and lightweight extruder. Its print quality is very good, it comes with an awesome hot end, and it's super lightweight for a direct drive setup, which helps prevent ringing, so you end up with crisp corners on your parts. My one complaint is it didn't come with a part cooling fan, but I was able to print one out of this clear PETG material, and that's been working really well for me. I also installed this flexible build tray, which was pretty much a necessity because the one that it came with wouldn't release the part when it was done printing. I think a PEI build tray like this is a worthy upgrade for any 3D printer because it makes bed adhesion and part removal so much easier. I also like this textured build surface that's achieved with some kind of powder coating process. You can use this for months of continuous printing without having to worry about it breaking down. The other big upgrade I made to this machine was the cooling fan on the bottom. That gigantic Noctua cooling fan helps keep things quiet and cool. I also installed these squash ball feet to reduce the amount of vibrations that get transferred into the table. Alright, now I want to take a minute to talk about the things that I really like about this machine. The best thing about this machine, in my opinion, is the drivetrain system. It's got dual Z-axis lead screws and stepper motors, so the platform is really stable. I feel that the extruder was kind of a weak point for this machine, because they used a smaller stepper motor than is used on the Creality Ender 3, and I needed to turn the temperature up because it was occasionally skipping steps while I was trying to print with it. I also like the software and the touchscreen interface on this machine. It's really well done, and one of my favorite things is that I can go into settings, and I have an option to enter G-code directly into the machine. You have this breakout board for the ribbon cable, so it's really easy to plug new stuff into it. That actually ended up making the machine easier to mod than any of the other 3D printers I've worked on. And my final thing that I really like about this machine is the fact that you can unbox it, set it up, and start printing in minutes. So you don't have to go through an instruction manual and figure out how to put all this random stuff together. If we look at the original print that I made on the FOKOOS Odin, you can see the print quality isn't great. This white color tends to mask some of the imperfections on the part. There's some rough patches down on the bow down there, and there's a really noticeable hull line. But if we look over at this one with the upgraded Biqu H2 Hotend, you can see the print quality is almost perfect. With the mods I've made to this machine, it's one of the best printing machines I have now. So these are now my two best benchies. The gray benchy on the right was printed on a Prusa machine, and the quality of it is outstanding. You can see there's almost no distortion in the reflection coming off of the bow, which means that those surfaces are super smooth and consistent. But we also notice the same level of print quality on the FOKOOS Odin with the Biqu H2 Hotend. You can see those reflections, they're just like super smooth, super consistent layers. And just for comparison, I'm going to put the Ender 3 V2. This is a stock Ender 3 V2. You can see it's outdone by this FOKOOS Odin with the Biqu H2 Hotend. Alright, thanks for watching this video and my review of the FOKOOS Odin 3D printer. If you like this video, make sure to hit the thumbs up button, and if you want to see more videos like this, make sure to subscribe to my channel. I'll be doing more 3D printing and modding videos in the future. Whew, that's still hot.